All right, 6.3b, square root inverse defining domain and range. It's going to go on page 127 of your handy dandy notebook. Okay, so to start off with, do you guys remember the horizontal line test and the vertical line test from Algebra 1? Ringing some bells? Yeah? Okay, so the vertical line test, I'm going to write VLT for vertical line test, passes. That means it's a function, right? Means it's a function. Okay, yes? If it passes VLT and the horizontal line test, that means it's a, that's a lot of humps in my M's, just go with it. Means that it's a one-to-one function. Okay, do those ring bells? Okay, so the deal is the quadratic function, f of x equals x squared, it passes the vertical line test, but it does what with the horizontal? It fails the horizontal line test, right? So what that means is that its inverse is not a function. And that's why when I told you yesterday, when we take the square root of something and it creates this plus or minus, it means that it's a relation, not a function. Okay? In order for the quadratic to have an inverse, it must have a restriction. So instead of us looking at the whole quadratic, we only look at the positive half. And that's why we say, okay, we're analyzing x squared, but only where x is greater than or equal to 0. Relation. Okay, and so now this passes, so this will pass vertical line test and horizontal line test, which means that its inverse is a function. So what we're going to talk about today is domain and range and how the restrictions work for square root and quadratics. Okay, all right, let's dive in. I don't know why my highlights didn't go away. I don't know. It's just gonna be highlighted. Cool. I'll write over them. All right. So my thing got a little weird. This should say we're examining the graphs, and the graphs are, yours are fine. You have f of x equals the square root of x plus x minus 2, right? And then your inverse function should say x squared plus 2, right? So yours should have printed out pretty and right. However, mine came out weird. All right, so we're going to analyze each one of these, their domain and their range. So the domain of our f of x, remember domain is from left to right. So reading from left to right, where do I start on the x-axis? I start at 2, right? And I go forever to the right, which is positive infinity. So my domain is from 2 to infinity, okay? That's interval notation. And inequality notation, that means that x is greater than or equal to 2. Ringing bells? Okay. My range is bottom to top. So if I'm here at 2, 0, where does my range start at? What's my lowest y value? Lowest y value is 0, and then it goes to infinity. So 0 to infinity. That's my interval notation, and my inequality notation would be y is greater than or equal to 0. Do we remember doing domain and range? Still with me? Okay, now we're going to do domain and range of our inverse. So looking at the inverse, the domain and range here. So domain starting from left to right, I'm here at 0, 2. So what is my smallest x value? 0. And the arrow means it goes on forever. So the domain here is x is greater than or equal to 0. The range, what is my smallest y value? 2, and it keeps going forever to infinity. So y is greater than or equal to 2. Okay, does that feel familiar? No one feels like that's brand new, right? All right, so now let's pay attention. Let's notice that the range of our function and the domain of our inverse function are what? The domain, the range of our function and the domain of our inverse are what? The same, right? They're the same. The same. And when you look at the domain of our original function and the range of our inverse, what do you notice? The same. So what that means is that, in summary, for all functions, domain of f of x is the range of the inverse. And that's because yesterday when we were finding the inverse, what was the very first thing we did? What's the very first thing you do when you're finding the inverse of a function? You switch, right? You switch the x and the y. And what does x and y represent? Your domain and your range. So you're switching their values. You're switching what they are. Okay, so if I know the domain and range of my inverse, then I know the domain and range of my function. If I know the domain and range of my function, I know the domain and range of my inverse. Does that make sense? All right, so let's do one example together and we'll keep it pushing. So here we have the original function, f of x equals 3 minus x, the square root of 3 minus x. So the domain of this function, so starting from the left, this function is heading towards negative infinity. Agreed? So it starts at negative infinity. That's I wrote double negative. And the biggest the x values will ever get is what? 3, right? So my domain is x is less than or equal to 3. My range from bottom to top, what is the function doing? What is my lowest y value? What's my lowest? Uh-oh. 0. So I start at 0, but my y's are continue to grow and heading towards infinity. So my range is y is greater than or equal to 0. So knowing that, what would be the domain of my inverse? Which one of these tell me my domain? The range. The range tells me my domain of my inverse. So the domain of my, yes.
Is there a difference between like affinity and negative affinity?
Yes. Infinity on the y means you're going up, and infinity on the negative means you're going down. On the x, infinity, positive infinity means you're going to the right, and negative infinity means you're going to the left. It happens to the best of us. All right. So the range of the function tells me the domain of my inverse. So we're at 0, infinity, and it's describing our x now instead of our y. And the domain of our function tells us the range of our inverse, which is negative infinity to 3. And it's describing our y's now instead of our x. Okay. All right. Doable? All right. So that is your 6.3b.